there? Well, there usually is. And today, we're going to crack that code. We're diving into sequences and functions. These are basically the secret tools we can use to see and predict the hidden logic in pretty much everything. So let's jump right in with a classic puzzle. These dots are forming what we call triangular numbers. You can see how it grows. We go from 3 dots to 6 to 10 to 15. The pattern is pretty clear, right? But imagine trying to figure out the 100th shape in this series. You're not going to want to sit there and draw those dots, so how can we predict it? That's really the core question for today. So here's our game plan. First, we'll get a handle on what a sequence actually is. Then we'll look at 2 different ways to describe its pattern. One is a simple step-by-step rule, and the other is way more powerful. And finally, we'll see how this all connects to this really cool idea called a function machine.
All right, first up, cracking the code. Before we can start predicting anything, we need to learn the language. And it all starts with this fundamental idea of a sequence.
And it really is that simple. A sequence is just a list of numbers. But here's the crucial part. They aren't random. They're all connected by a specific predictable rule. Let's make this totally concrete. Take a look at the sequence. 4, 7, 10, 13. And it just keeps going. Each of those numbers, the 4, the 7, the 10, we call that a term of the sequence. So the first term is 4, the second is 7. You get the idea. Okay, so just look at those numbers for a second. What's the hidden rule here? How are we getting from 4 to 7, and then from 7 to 10? That rule is the secret ingredient, and finding it is always our first move. So once you spot a pattern, how do you describe it? Well, the most basic way is to give directions one step at a time. Kind of like saying, walk to the corner, then turn left, then go forward 50 paces. It's all about the next immediate step.
In the world of math, we call this the term-to-term rule. And it does exactly what it sounds like. It tells you precisely what to do to get from one term to the very next one right after it.
So for our example, 4, 7, 10, 13, the term-to-term rule is just add 3. It's that easy. 4 plus 3 gets you 7, 7 plus 3 gets you 10, 10 plus 3 is 13. It works every single time. This is our simple, step-by-step roadmap. But, and this is a big but, this simple rule has a major flaw. It's fantastic if all you want is the very next number. But what if you want to take a giant leap forward?
Yeah, here's the problem. If you wanted the 100th term in our sequence, you literally have to apply that add 3 rule 99 separate times. It would take forever, it's super tedious, and honestly, you'd probably make a mistake somewhere along the way. There's got to be a better way, a shortcut.
And that shortcut is what I like to call the power rule. If the term-to-term rule is like giving those step-by-step walking directions, then this thing is like having a GPS. You just type in your destination, say the 100th term, and bam, it takes you there instantly. To get there, we have to rethink the problem a little bit. Check out this table. Instead of just looking at how one term relates to the next, we're now looking at how a term's position in the line relates to its actual value. So, the term in position 1 has a value of 4. The one in position 2 has a value of 7. You see? We're looking for a whole new kind of connection. This new, more powerful connection is called the position-to-term rule. It's a formula that directly links any term to its spot in the line, and you'll often hear it called the nth term, where that letter n is just a stand-in for any position number you can think of. And for our sequence, that magic GPS formula is 3n plus 1. Let's test it. For the second term, we just pop a 2 where the n is. So 3 times 2 is 6, plus 1 is 7. It works! So, what about the 100th term? Easy. 3 times 100 is 300, plus 1 is 301. We just jumped there in one go. No more adding again and again and again. So this really shows you the difference, doesn't it? The term-to-term rule is sequential. It's all about the very next step. But the position-to-term rule, our nth term, gives you this amazing ability to find any term you want whenever you want. It's basically the difference between walking and teleporting. Okay, let's take this idea just one step further. We're going to connect it to one of the biggest ideas in all of math, functions. And honestly, the easiest way to think about a function is to picture it as a machine that follows a recipe. I mean, look at this diagram. It's the perfect way to see it. You drop a number in one side, that's your input,
The machine works its magic based on a specific rule, and then a new number pops out the other side, and that's your output.
We can really break this process down into 3 simple steps. You start with an input, which we'll call x. The machine applies its rule, something like multiply by 2 and add 1, and then it spits out an output, which we'll call y. Input, rule, output. Simple as that.
Let's watch one of these machines go. In this example, the rule is y equals 2x plus 3. So if we put 0 in for x, the output y is 3. If we put in a 1, the output is 5. If we input a 3, we get 9. For every single input, you get 1 and only 1 output. Now take a look at those outputs. 3, 5, 9. What do you know? They're forming their very own sequence, all created by this one function. And that right there is the big aha moment. A function is really just a more formal, more powerful way of writing our position-to-term rule. Our old rule 3n plus 1 can be written as the function y equals 3x plus 1. The position number is just the input x, and the term itself is the output y. It's the same exact idea, just, dressed up for the big leagues.
So there you have it. We went from looking at simple dots all the way to a powerful algebraic rule. And this way of thinking, finding a rule that can predict a pattern, is absolutely fundamental. It's how economists build financial models. It's how animators program the movement in a video game. It is all about cracking the code. So the only question left is, what pattern out there in your world are you going to look for next?